Hello, I'm Dr. Chris Benton, and I live on the beautiful Hibiscus Coast in New Zealand, where I was a family physician to the local community for over 30 years. In 2014, I semi-retired, allowing me to return to university for a master's degree in astronomy, while still continuing my passion for medicine. I am now fully retired, living the dream, communicating in plain language to general audiences on astronomy, medical ideas, and human spaceflight. Have you ever wondered what does happen to the human body in space? What challenges are there for future astronauts traveling to Mars? I will tell you what happens to us in space, why it happens, and why it matters. You will discover what sort of shape astronauts will be in when they get to Mars as we face the human body's next frontier. So here's a couple of astronauts, or I should say American astronaut Scott Kelly and the Russian cosmonaut Mikhail Kornienko. And these look sort of, pretty average sort of guys, don't they? Look pretty normal. Nice sort of, sort of facial features, chin, creases in his neck, nice, normal jawline up there and so on. And the same for Mikhail. So let's put them in space. So that's pre-flight. Let's put them in space. Check that out. Look at them, look at their faces. Look at they're all puffed up. You can hardly see their chins. Their necklines have gone. All their faces are puffed up. Look at their upper chests, all their upper torsos, all pumped up and stuff. That's what happened to them. And this change happens really quickly in space. Blood tests, if you don't like getting your blood test done, guys, don't go up into space, because that's what you're going to get done plenty of times. So they check for the electrolytes, that's sodium, potassium, their blood counts, that's their red blood cell counts, the white cell counts for the part of the immune system, platelet cells for clotting and so on. They'll do their liver and their kidney functions regularly. Biomarkers, that's sort of chemical markers, indicators of if the heart's under strain, factors of if there's excessive bone loss, certain biomarkers start to rise in the blood. If there's a potential clot going on somewhere in the system, markers called D-dimer, that will start to raise. So there's all sorts of biomarkers they can do to assess what's going on inside them. And this is relatively easy, non-sort of invasive stuff to do. Have you ever looked up at a beautiful, starry, dark night sky and wondered whether you're looking at a star or maybe a planet? Maybe what type of star or planet could that be? I'll teach you about stars, about planets, and our Milky Way galaxy, such that you'll then know exactly what you're looking at and how you know. So here's a nice picture, Southern Hemisphere winter view. So what you're seeing here across, what are you looking at when you're seeing this lovely big strip along here? It's known as the Milky Way, because it just looks a big blur to a degree. And it was Galileo with the first guy to take a telescope and look up into the skies. And he had the insight to realize the Milky Way, which means spilt milk, because it looked like a big spill of milk, was actually, you're looking at billions of stars so distant we can't resolve them with our eyes. And that's why it just looks like a big milky blur. Here's that bright, dense central bulge again, looking back here. So that's the bulge that we're looking back at. That's it here. You might say, well, all these big dark, dusty big lanes and things going through here. That is, dense clouds of gas, in particular dust. They're not very big dust particles, but there's just zillions and zillions and zillions of them out there that make up throughout the plane of the Milky Way, and they get in between us and the stars behind them, and they create those big dark patches there. So that's what you're looking at. That's where future stars will be formed in those regions. So let's look at some individual planets. Mercury and Venus, you'll always see them close to sunset or close to sunrise. They hug the sun. Why do they hug the sun? Because their orbits are closer to the sun. They've got the sun, you've got Mercury, you've got Venus, then you've got Earth. So from our perspective, they're always going to appear closer to the sun. So they hug the sun. Mercury's reasonably faint because it's small. Venus is always very, very bright. There's a few reasons why. One is it's close to us. Two, it's relatively close to the sun. And the third one is it's got a global, thick, dense cloud cover around it. And clouds are wonderful at reflecting light. So there's three reasons why Venus is so bright. And for that reason, it's often known as the morning star in the east, if it's near sunrise. And if it's near sunset in the west, it's called the evening star. Every day, we learn more about the universe. I will show you what you can observe and discover using a simple pair of binoculars. Telescopes are great tools to see deeply into the galaxy and observe stars at different stages of evolution. I'll show you how stars are born, how they live, and how they die, and how you can recognize these objects. Furthermore, I'll tell you how astronomers measure the distances to these faraway jewels in the sky. If this P were the Earth, on the same scale, the Sun would be this Swiss ball. Did you know the Earth fits 1.3 million times into the volume of the Sun? I can show you the true dimensions of our solar system objects relative to one another. You'll be surprised. Here's your little treat for Mars. I love that picture. That's in Gale Crater, and it's the track marks a few days prior of the Curiosity rover. I just love that. It's just so wonderful. You know, we can't help ourselves. We've got to leave our mark on the planet. So I just love that picture. We fragile humans live on a fragile planet in a truly wonderful but unforgiving universe. Buckle up and I'll take you on an exciting journey from how we cope with spaceflight into the far reaches of space. I'm looking forward to seeing you all soon.